All right, number 7, we have a sample space. We have the numbers 1 through 10. We're going to suppose all of these are equally likely. We're going to compute the probability of event E, an odd number less than 7. So an odd number less than 7. So if I want to think about an odd number less than 7, I can use my diagram now. So I'm looking here. How many odd numbers do I have that are less than 7? 5, 3, and 1. So there's 3 numbers out of the 10 that I have total. If you leave it as a fraction, just 3 over 10, or you can convert that to a decimal, that would be 0.3, 30%. So it says type an integer or decimal, do not round. So we're looking at 0.3 because there's 3 numbers that are odd and less than 7. So an odd number less than 7, got to fit both of those. Number 8, we have 4 parts. Says we're going to complete parts A through D. So Wall Street Journal publishes an article entitled "The Count." In one article, the count looked at 1,000 randomly selected home runs in Major League Baseball. So of 1,000 home runs, it was found 75 were caught by fans. What is the probability a randomly selected home run is caught by fans? So based on this experiment, we would do 75 over 1,000. This would set up our probability. And then we would reduce this. Both of these numbers are divisible by 25. So that would give me 3. And then 10 divided by 25 would give me 40. So 3 over 40, I would have to use a calculator to do that, or I can do it by hand, but calculator just speed it up. So 3 divided by 40 is 0.075. Let's just confirm that we reduced that, right? 75 divided by 1,000. Yeah, 0.075. Okay, so 0.075. B says of the 1,000, 263 were dropped by a fan when a fan had a legitimate play on the ball. So we want to, what's the probability that it's dropped? So it'll be the same thing. We're going to take this 263 divided by 1,000. We get 0.263. C, of the 75 caught balls, it was determined 29 were barehanded, 38 with a glove, and 8 were caught with a hat. What is the probability a randomly selected ball was caught in a hat? Okay, so 8 were caught in a hat, so it's still the same. 8 out of the 1,000 were caught by a hat. So 0.008, I think. 8 divided by 1,000. 0.008. So the probability 0.008. So for every 1,000 home runs caught by, so for every 1,000 home runs, nope. Approximately, so for every 1,000 home runs caught by fans, we expect about to be caught in a hat. It seems that the wording, I don't like the wording, or that they may want to do some conditional, which that's a little bit more advanced. We would expect to have been caught by a hat. Oh yeah. But see, this isn't 1,000 home runs caught. This is 1,000 home runs hit. 75 were caught by fans. So let me do 2 calculations because this wording is a little weird. So let's say 8 are caught in a hat out of 75. That means how many would be caught out of 1,000? So we can do some cross multiplication. I'm going to multiply by 1,000 and say 8,000 divided by 75 and find out that number. 8 divided by 75. which gives me 106. And what does it say? Round to the nearest thousandth for my percent. So 106, roughly 107, maybe. So probability is, so for every 1,000 home runs caught, we expect about blank to be caught in the hat. What's the difference in the probability is? So for every 1,000 home runs caught by fans, we'd expect exactly. So this one says exactly. We don't know exactly. This is about. So this is, we're going to go with B. So 0.008 was a probability. If that's what we're looking for, we would expect out of 1,000 about 107 to be caught based on this calculation. So we know 8 out of 75 were caught, so roughly 103 out of 1,000. Okay, so they don't like it. So let me change the probability that is caught in a hat. It's going to be 8 divided by 75. Let's do that one. So roughly about 0.10 tens, 100,000. So about 107. About 0.107. Yeah. Okay, so they're looking kind of like the conditional probability that the ball was caught. So of the 263 dropped, it was determined that 203 were bare hand attempts, 48 were dropped with a glove, and 12 were dropped with a failed attempt. So we're focusing on the drop. What is the probability a randomly selected drop ball was failed with a hat attempt? So we dropped the ball, 12 were dropped with a hat. Okay, so out of, I don't know why that focus is trying to zoom. So it's saying out of the drop balls, 12 were dropped with a hat. So we're going to do 12 out of 263 that were dropped. So this will give us our probability of being dropped with a hat. And then every 1,000, we're going to do it again, cross multiply. So out of 1,000, how many would be dropped? So I just multiply that number by 1,000. So let's do 12 divided by 263. We get about 0.046. So if I multiply this by 1,000, that tells me about 46 out of 1,000 would have been failed with a hat if 100 or 1,000 were caught.